Welcome to the Startup Grind.
My father was an aerospace engineer for General Electric, and instead of growing up as a young child coloring in color books, I grew up tracing airplanes out of Aviation Week and Space Technology. He used to bring that home. So I think that's really where it started. I got my first taste of flying with my uncle, who was a Korean War pilot and had a private airplane, and took me up on that. I was probably going to do something completely different until he took me up in that airplane, and that was it. So I went to the Naval Academy for 4 years, graduated as an aerospace engineer, probably not a shock there. Went to flight school, and moving to Boise was our 14th move. Lived all over the country, all over the world. Spent one tour in California where I had a flight test squadron, where I had 19 very large unmanned aircraft in the fleet. We'll talk about that later. But then I decided it was time to retire. I wasn't going to have any more fun than I had already had. I looked at opportunities, and kind of contrary to everything you learn when you're getting told how to find a job, you need to have connections. I found this internet advertisement for a job in Boise, Idaho, and went home and asked the wife, and she said, well, we've never been to Boise, but we like out west. We were both actually high school sweethearts from upstate New York. And so I applied for the job, and if I don't tell you, my wife will tell you. So I almost didn't go to the final interview for this job because I had a bunch of other offers. I thought, I'll just blow this off. I got to go down to D.C. And she said, no, you're going to go down. You're going to do your best. And I got the job, and we've been here for over 9 years. And I love the community. My son is out here now. I'm a Boise State graduate now. Just got my executive MBA. And I love the startup community and helping new emerging businesses and trying to bring aviation here to Boise. There's so much opportunity here. So that's, yeah, and along the way, a bunch of carrier landings, a bunch of fun test flying, and a bunch of really great people. And now I get to be with these great people. I've been talking to companies down in the Bay Area, back east, all over there. Are just such new thought and technology going into this space. It's really amazing. I've been talking to them a lot about kind of the things that I think are going to be really important to move this industry forward. And I have a top 10 of technologies that really need to be developed. I've been talking to them a lot about that, and one of the developments that's going on here, Terry's group is working on it, is this sense and avoid problem. So you go up in an airplane, you're a pilot or you're a passenger, there's someone in the cockpit who, despite anything going on, whether there's radar control or not, their job and the foundation of our whole airspace and flying is I can see another airplane and I can avoid it. And until we develop that technology, and there's a lot of effort being done right now in what I call cooperative sense and avoid, so using radar or other cooperative means. And really, if you're going to get true integration into national airspace, you're going to need to have a non-cooperative self-contained sense and avoid capability, and that's being worked on here. It's being worked on in other areas. Up in Michigan, there's a startup with some VC money that's working that. A bunch of folks in the Bay Area. It's not an easy problem, but it's one that is extremely important. But there's a ton of those technologies. A lot of other folks working on different business areas where I think that we've heard about precision ag, and shout out to Adavso. I was on a conference call today with a bunch of Senate staffers and the FAA, and they got a shout out from the FAA as being one of the first precision ag recipients of a 333 exemption, which allows them to fly commercially. And so there's a lot going on. It's interesting, as I go all over the country, there's a lot going on, but I come back here and there's a lot going on, and some of the folks here tonight I didn't know existed until this week. And so I wonder how many are out there in the woodwork that we still have to go find and really help cultivate here in the valley and in the state.
Okay, so Mark has what he saw, the predictive list that the FAA is going to go through and give FAA exemptions to. And the first one that he had listed was the movie industry. And the next one on his list was precision agriculture. And he had this listed out in order of what he saw was going to be the next order of exemptions we're going to see. And sure enough, we're really excited to see precision ag in the last 3 weeks got that checkbox. The first precision ag FAA exemption. So this is a really big deal. Will you share with us for a minute why the movie industry, and then maybe the rest of that list that you have?
Sure. So before you start asking me for lottery picks or stock picks, the reason I got these two well is I think I understand the FAA and what they're up against. And let me first say there's a lot of FAA bashing, and I'm a Fed, so you can bash us because sometimes we deserve it. But FAA is really faced with a difficult challenge. They've got this new technology, and they're being asked to introduce this new technology, and there's a tremendous push from the private sector and the commercial sector. There's tremendous capabilities out there. It shows tremendous promise. $89 billion industry kind of waiting at the starting gate. On the other hand, none of us who fly, or actually none of us, even if you walk, want to have the airspace be less safe than it is today. In fact, we'd even like it to be more safe. So really this list came from my knowledge of what the FAA is up against and what their likely plan would be. So they're trying to balance, moving it forward, but also mitigating the risk. And so when I was out in California, I got to be on a couple movie sets. It's a long story, but so I got to see how movie sets operated, and they're extremely professional, and they operate with closed sets. A lot of their control is to make sure that what they're filming is done right. You don't have an airline flying over or someone making noise while they're trying to get a shot. And it's that process and procedure discipline and operational discipline, and the fact that they're using them in a very small footprint, on a set, even if it's outside, that I know from the FAA is what got them to agree to grant those folks a 333 exemption. And that's not a blanket exemption for every movie company. They had to prove themselves before they were given that. And then precision ag, again, looking at the relative risk, if you're talking about agriculture, you're probably not near big cities, you're probably not near airports. It's mostly going to be private land, and so again, the risk there was low. So then the next one on my list, and it's already really happening, I guess I could have put a check mark there, is the government domestic applications. So for years, government agencies like mine and others have been able to apply for a certificate of authorization to allow us to fly unmanned aircraft. But we've had to use our own aircraft or certify our own aircraft. We have not been able to do it commercially. I run a very large aviation enterprise, and about 70% of the flying that's done, we fly about 70,000 to 80,000 hours a year, is contracted. And I expect that eventually, when we are able to fully employ unmanned aircraft, it'll be about the same percentage. So we are now at the point where the FAA is going to allow us to go out and contract, and we'll likely get some exemptions for those companies as well.
Fabulous. So when we're talking about the certificate of authorization, we call them the COAs. And so if you want to go out and fly, you have to file for one of these COAs. Now, so my question to you guys is, how many of you guys are interested or are using UAVs in your business right now? Raise your hand if you guys are.
I won't report you, trust me.
Yeah. Yeah, it's how many of you are using them but don't want to raise your hand? So let's talk legal issues for a second. So you can't fly drones for any commercial gain at this point. Do you want to talk to us about some of the legal things that are going on and what laws there are right now?
Right, so how many people own a drone or UAS? Okay, so probably most of you are flying it as a hobby, and that's perfectly legal. You're supposed to be flying it in accordance with a body of rules. It's normally set down by the Aircraft Modelers Association or some other organization you might belong to. And there have been lots of places you can do RC, remote control model work. The challenge that we're facing, and it's caused all this hubbub, so I can talk from my personal experience. When I was a kid, I think the first that type of aircraft actually had a string at the end of it, right? And it wouldn't go any farther because it was on the string. I could twirl it around in a circle. That was great. And then we had the radio controlled ones. Well, the power of the radio transmitter and the sensitivity of the receiver really prevented us from going very far. It's kind of like those walkie-talkies you used to have as a kid. So it might go 100 yards. Well, now you can go into the Cabela's and buy a walkie-talkie. You can talk probably 40 miles. And so the capability of the vehicles, from having onboard cameras, GPS, these high-powered radios, and the fact that to be a drone pilot, you need a credit card and an internet connection, right? And you can go get one, and a very, very capable one, and that's caused some concern. So even if you're not using it commercially, it's a potential hazard. And so the legal issues here have really been around safety, first and foremost, and then there are also the privacy issues. No one ever cared about me flying my remote control airplane over them because I wasn't carrying a GoPro, and they didn't have to worry about what I might be seeing in the backyard or whatever. And so you now have that capability. All this technology has really sensitized folks to this. And it's interesting when I look across the international spectrum. I said the FAA gets bashed a lot, and the international community has really been the wild, wild west. But it's a funny thing. Every day I read articles about happenings in Europe, in Australia, Southeast Asia that are very concerning to those governments, and all these calls for new regulations. 2 days ago, there was a drone flying over the French presidential palace. Now take a look at what's been going on there and how concerning that would be. A few weeks before that, there were drones flying around French nuclear power plants. So what we're seeing is the international community is trying to put the genie back in the bottle. And we're trying to, responsibly kind of open the bottle a little bit and let some out. So those are the kind of issues. And a lot of us who deal in this area, because folks are new to it, they don't understand some of the responsibility they have. These things can get away from you. Most of them, one of the big weaknesses, they operate on frequencies that are common to many other things. 2.4 or 5.2 gigahertz is exactly what your broadband is at home. So if it flies through a frequency that happens to be broadcasting at a higher power than your little controller, guess what? It likes that one better than it likes yours and can take off. And think of them as very hard birds. And I've been hit by birds in the sky and have lost engines and had structural damage, so I would not want to be hit by one of these. So that's kind of the basis for the legal thing. I know people think, that's a small little toy, why should it matter? But it matters a lot if you're the one that gets hit by it, or if it's peering in your backyard and you don't want to do that. So I think we're moving in the right direction. It's obviously slow, and we can speed up, but I think we're doing a better job than they are in the international community because they're having a real challenge to try to get that genie back in the bottle.
So one of the reasons we did tonight's event is I wanted everyone to get a feel for who are the players locally in the UAS space. And when you think UAS, you think drone. But what there's so many opportunities in the entire industry. And the people that are running the drones, there are different, if you're looking at in situ or anybody, there's so many opportunities surrounding just the drone that are, as Mark calls, the holy grail of opportunities. And so he's actually created a hierarchical list. Again, he's very orderly.
I'm an engineer.
He's a background in this. And so if you flip your papers over, he has like the holy grail of opportunities that are going to come through the UAS industry. And so the fun part is being a room full of entrepreneurs and people that think creatively. This is an opportunity for you guys to fill these holes that they have in the space. There's so much data being collected from all the systems that are out there. There's so many safety issues. And so, Mark, talk us through your holy grail of opportunities.
Sure. So I'll start with the top 10 technology challenges and payoffs, because if it's a big challenge, it's also a big payoff. And again, we talked about the number one is this non-cooperative, self-contained sense and avoid. Because that is the one thing that's preventing the unmanned aircraft from really entering into the national airspace system. Because our national airspace system is based on fundamental precept that I can see you, you can see me, and we don't have to have radio contact or radar contact. We know to go, avoid each other. And so until we get the opportunity to do that, we're going to be constrained. And all these systems that rely on electromagnetic energy, whether it's radio communications, data link communications, radar reflections, that's a weakness. So if I go flying in a plane and I lose communications, and anyone who's been a pilot or is a pilot, I guarantee you've probably lost communications, or someone hasn't been able to read your transponder, or someone has lost radar contact, but you still knew what to do. You were on a flight plan, very least you follow the roads. Unmanned aircraft that loses that communication, it's got to decide what it's going to do, and it's usually programmed in to do that. So that's why I say these things have to be self-contained. And of course, if you're an engineer or a physicist, you know that as you get farther away, that signal drops off precipitously, and the power required to keep that signal going, it goes up tremendously. So that's why this one is so important. And again, one of the aspects that we have to deal with, and we're in a partnership with NASA, and at least one of the companies here and the university here in this partnership on this unmanned traffic management system. We don't have traffic management in the air below 500 feet, except around airports, because we aren't supposed to fly below 500 feet on a regular basis. And so if you're talking about having some kind of ground-based system, you're talking about, in my view, a tremendous number of radars and those types of systems. In fact, I originally thought that Google was going to crack the code first. And then I saw a Google self-drive car down at the Ames Research Center, and I thought, they don't care too much about weight, they don't care about power, and they don't care about size. If they were to be able to miniaturize that, I think that they would have a possibility. But they're also using some active technologies there. Again, as soon as you start using active technology, you run into some challenges. But I do think that they and a few other companies are on the right space, on the right direction. But that's the first one. The other thing about unmanned aircraft, and I get this all the time because folks want, in my business, they want an unmanned aircraft. They're not really sure why, but they want one. And what we found in the Department of Defense is when you put an airborne IT node, an IT node up in the sky, a data collection point, you start getting a tremendous amount of data. And it was about 24x. Do you have the pipe to bring it down? Do you have the ability to store it? How many analysts is it going to take to analyze it? And how do you turn a data point into a trend? And how do you compare that trend against what you expected or what you saw last time? And then how do you turn that into knowledge of how you're doing and whether or not you need to make a change or what you did is working? And that whole decision loop is not a trivial pursuit, nor is the technology to be able to absorb, collate, store all this data. And so I put that as number 2 because it's really the reason we put it up there. Otherwise, it's just cute pictures and pretty video. You need to be able to do something with it, and that's where the tremendous opportunity lies. The control link, system integrity, redundancy, security. Again, the big weakness with unmanned vehicles is this two-way communication link and the two-way data link if you're downloading video. And it's a tremendous concern for us in the government. We don't want a 12-year-old kid or a bad person taking control of our unmanned aircraft and sending it where we don't want it to go, maybe into a building. We also don't want you to be downloading the video that we're taking. Maybe it's on a fire and someone's house just got consumed by a forest fire. We don't want you to take that and post it on YouTube. So we have to have that control link secured. So that's a big deal. And so that's kind of 3 and 4. And then we go to the low altitude traffic management system. Number 6 is a fun one because I didn't have this on my list originally. I live here in Meridian and I was out in my backyard and I thought, this is cool. I don't know who it was in my neighborhood, somebody had a Batwing UAV and they were flying it around and I thought, wasn't that cool? And then they brought it out at night and they had LED lights on it and there were 2 of them. I'm a fighter pilot. There were 2 of them fighting. I thought, oh, this is so cool. The third day, as I was sitting in my hot tub and hearing this swarm of angry mosquitoes flying overhead, I thought, I am sick and tired of this thing. It's a nice peaceful day. I don't want to listen to this. So I think noise reduction technology is a huge one that's being missed. And we put 1,000 of these down at low altitude. You have a really annoying noise very close to the ground. You see airplanes flying over all the time, helicopters, they're there, they're gone. If they're higher, the farther the distance, the lower the noise signature. So I think that's a big area. Interoperability, everyone, this is like the early days of the industry, auto industry. Everybody's got their own make and model, and none of them fit. So we're talking to some companies, a lot of them I've been talking to, what are you doing to make a universal controller, a universal autopilot? Because I want to have a fleet, but I only want to have one controller of all different types. And so I think that's a big area. Most of these, particularly battery-powered ones, have a very low endurance and range, 45 minutes. How far can you go? 45 minutes, 30 miles an hour, you can do the math. And it takes a while to charge the batteries. So I think power enhancements. I know Idaho State University and some other folks are working on new battery technology, and that's a big one. Spectrum and system safety enhancements. Another weakness, another big to-do for the federal government is what frequency are these things supposed to operate on? There's no dedicated frequency. We know what we operate on for cell phones, for our walkie-talkies, for our UHF radios. For this, it's kind of all over the map. And so we're piggybacking pretty much on the broadband frequencies. And that's not good because they can take control. Sometimes you can't see it through the air, so you fly through a beam that's on the same frequency but more powerful. Your drone may go to 3,000 feet and fly right in front of a plane. So that has to happen. And then the system safety things, building them to a robust nature so they don't fall out of the sky. I just watched a video. It was kind of a funny video, and it's this great company, DJI, the Phantom folks, right? They put out this new one, and they had to redo the firmware because there was some wobbling. Well, they show the video of this guy taking it off. He's in the road between his neighbor across the street and him. Thing takes off and flies right into his neighbor's garage and just obliterates itself. And so it needs some system safety. And then eventually, once we get this industry more mature, it'll be the commercial standards, and you'll be able to go down to the drone store and buy a part that fits everywhere because it'll be a standard. So that's the top 10. And those are just the technology areas. So I think any startup, any business that's currently operating in a similar area, I think these are opportunities to move into this space in technology. The question was, thought there would be something of a more active, where you air traffic control grounding system, like in 9/11, we put all the planes on the ground. We told the pilots to land. How do you do that in a drone situation? That's actually part of what the unmanned traffic management system development that NASA and other agencies and companies are currently doing. That's what they're looking at. Again, that's a weak link, because if I give you that signal and you happen to be behind a building, a hill, or whatever, don't get that signal, then I didn't do, I could just keep that beacon going the whole time, and eventually you'll come out and land. But yeah, I think that'll eventually be part of the system for that very reason, for safety. But it's not really something that I think is going to be built in to help the industry, but it is being looked at in the traffic management system.
Yeah, if you're going to operate in Class B aerospace.
Right, and where I'm talking about most of these applications is in the low altitude structure. Because once you get into the mid-high altitude structure, you start looking at larger airframes, and then the issues of weight and power, form factor, they kind of go away. Like you'll be like a Global Hawk or a Predator. You're going to have space to put in, radio relays and transponders and those kind of things that will make you pretty much just like an aircraft. And you'll be under radar control because you'll be in airspace where we've designed a very robust radar coverage system for that. So the question was, does the FAA have anything going on in large buildings, enclosed structures, or not? So here's the great news. So I was up at the University of Idaho, and they have the greatest indoor UAS test facility. It's called the Kiwi Dome. So the FAA actually has no jurisdiction in what they call non-navigable airspace. So we probably shouldn't tell JD, we could be flying this drone on here all the time because this is not airspace. So large warehouses, indoor stadiums. We originally were trying to get this in the facility the president spoke in yesterday.
Kind of got bummed.
Well, you know, we're pretty high, but not that high, you know. So yeah, and that's a great opportunity. I think there are even some business opportunities there. You know, I could see a new paintball laser tag indoor with drones flying, back and forth. But that's a good point. You can do those kind of operations. You can test products out. I was down with a company in San Francisco, and they had a big open space in their building, and that's what they did. And then on the roof, they had a big net that covered the whole top of the roof, and they could fly in there. It was outside, but it was non-navigable airspace, and they made it that way. You can also tether a drone. I don't really recommend it because it just becomes a very angry drone if it gets out of control, Imagine a rabid dog on a leash. I'm still not thinking that's a good thing. Sure, so the question was about operating UAVs up in the what I call the regular airspace, class A, B, C airspace, where aircraft normally operate. I think there's, I'll talk about some of the biggest challenge, right? The biggest challenge is those aircraft tend to have to be operated from an airport because they're larger aircraft. In my organization, we focus on what we call airport independent UASs. So hand launched, catapult launched, vertical lift, so we can launch them from areas that we control. I mentioned my bio was at Point Mugu, California. It's on the coast. Our base was on the coast. We had 19 QF4s. We flew them both manned and unmanned. I could not launch them unmanned from the base, even though there was really nobody around there, because of the public's concern that might fall on somebody. So I think that's going to be the biggest challenge. Anybody operating or living around the Boise airport is going to be a little bit nervous thinking of a larger aircraft launching from that airport. And then there's the issue of getting them up through the airspace. You had mentioned Google. I think that's a great example. They just bought a company not too long ago, Titan Aerospace down in New Mexico. Titan Aerospace was working on a concept called a solar atmospheric satellite. And it's basically a huge high aspect ratio glider with embedded solar cells and an electric pusher prop. We launched that at night with a full battery. We climbed to 65,000 feet, which is above the normal airspace structure. And we'd get there right in time for sunrise, and depleted battery, we'd charge the battery, and it would be up there for 5 years. I talked to the company, found out that 5 years is based on the amount of times they can discharge and recharge the battery before it has to come back and land. So that gives, so Google bought this company, I think, to possibly have a worldwide internet capability, put internet where you don't have the infrastructure for it now. But the interesting thing about that capability is you just have to get it up to 65,000 feet once and then back down in that 5 years. So the risk is low. I think this is going to be an area that's going to be slower to develop than the small unmanned aircraft arena. And that's the first rule that the FAA is looking to develop. So we can do this work down low. And frankly, every one of these top 10 is based on the assumption that that's the first one that's coming out. Yeah, so the question was, what's the distinction between hobby and commercial, and what kind of distinction is the FAA making on that? It's a very interesting problem. And really what they're doing is they're saying, this is what it means to be commercial. And we hope that everything else is hobby. And I'll talk about them. And then I'll talk about what they have in the UK, which I think is an interesting concept. I'm not sure we could do it here. But what the FAA has said is, if you fly for compensation, or as my friend Robert Blair, who owns a farm up north, found, if you're flying to help yourself in your own compensation, he's doing work on his own field, so he's not paying himself, but he's getting the commercial benefit from that, then that's considered commercial, and you're not allowed to do it unless, like a DAVSO, you've got a 333 exemption, or later on, when they come out with the certification requirements, you meet those. And so the FAA is saying, okay, everything else has got to be hobby. And
And that's a challenge because, again, we have this capability we've never had before, and not just in the aircraft, but in the systems that are carried on the aircraft. And so what they've done in the UK, I think is very interesting, and we actually talked about that today in a briefing I was at. So if, in the UK, if you carry a camera, then it's not hobby. Because you're obviously doing something. You're not, what hobby used to be, how well can I fly my aircraft? Can I make it do loops and look what a great paint job I have on this model airplane, right? I mean, that was pretty much the extent of it. But now it's a lot more. So I think they may be onto something. We talked about this, we talked to some of the staffers. We weren't really sure that we could get that kind of legislation through. But for us and for the FAA, if you're not doing it for commercial purposes, then you must be hobby. So a question, so JD does the X+1, and so when you're developing it, right, and that's a question that I've been asked a lot when I go around to various UAS companies, and it's what I find is the companies that are developing UAS are being very, very responsible in how they develop and where they go because it's a potential livelihood. And so they have not become a problem. And frankly, the FAA has a lot more work to do to go after folks that are flying near Chicago O'Hare and JFK and all those other things that I think that's just, they haven't bothered with that, frankly. But you do raise a good point, and I'll ask that when I talk to the FAA tomorrow, how they're dealing with folks there. But I know they understand that folks are developing systems, and they need to do that. Again, find a nice warehouse, you can do that without any trouble. Yeah, and so the question was, well, aren't these a real risk when it comes to a potential weapon of mass destruction? How are you going to stop this? And I mean, the reality is that when we saw this in 9/11, you could do this with an aircraft. And all you need to do is learn how to fly, right? And so I think it's always going to be a challenge. It is a new challenge, a potentially greater challenge in terms of the size and the ability to detect that. A lot of the unmanned traffic management system is talking about that. But in my view, that unmanned traffic management system, it may be great for putting out a signal and telling everybody to land, but it's not going to be what we want for safety, for just general navigation, and that's what I think is going to be happening most. Yeah. So the question was, if you're flying flying your hobby drone in support of somebody, and yeah, that's a challenge because it's not really legal under the commercial applications. Because someone's benefiting from the work that you're doing. And that's why there's so much pressure on the FAA to come up with the small unmanned aircraft rule so that everybody can operate that way. And the risk mitigation right now is 333 exemptions, which give companies who have proven their ability to operate responsibly. And so on the back here, I had these kind of business areas. And this one, DAS, drone as a service. I think there'll be companies that will come together, maybe like a DAV, so that people will gravitate. Oh, you have a 333 exemption. Oh, can you do this for me? And it's kind of interesting because of the exemption process. They've got a head start. It's almost like a government-installed monopoly for a little bit until everybody else catches up. But it's one of the ways we're seeking to mitigate the risk from bad folks getting involved, from folks that don't know what they're doing getting involved. We don't want to be like the rest of the world's been and have it be the Wild Wild West and then try to rein it in. I know it's frustrating. Again, the technology has developed so fast, and it seems so easy to use, and it is. That people want to get out there and use it. It's really fascinating to me. In 1903, Orville and Wilbur took a two-dimensional species and gave us a third dimension. But for over 100 years, that has been very, yes, Kitty Hawk too, and It's been expensive. You know, you got to buy an airplane, you got to get flying lessons. It's tough to do. You just don't walk out your garage and get in your airplane. You know, we don't have jetpacks, we don't have plane cars either yet. And all of a sudden, every person is three-dimensional capable. It's really 3 dimensions for the masses. So, you know, going up and seeing the wonders that people see from airplanes, you know, putting a GoPro on a quadcopter and flying it down Hell's Canyon, you know, taking a look at what your house looks like from the top and not having to pay a few $1,000s to go rent an airplane and do that. I understand the interest and you know, why people want to do this, and it's a really amazing technology. What I hope that we all do in the government and those of us that have unmanned aircraft, that we use them responsibly so that you know, this industry can grow, and that's really what I'm here is tonight to do, is to promote this industry.
So we want to thank you so much.
Thank you. Thank you. Thank you.